So remember, we can think of our domain of our function as our input, the things that are going into our machine, and we can think of the range of our function as our output, the things that we get back out of our machine. So for example, let's take our function f of x, which is equal to 4x plus 1. Now, if we start with the domain and we think of all the things that we can put into this function, well, it doesn't matter how big I make my number, how small I make my number, whether I choose a 0, I can multiply any number by 4 and add 1 to it. So the domain, in this case, we see is unrestricted. In fact, I can have any number go into this function. And the way that we write that mathematically is that we say our domain is such that x belongs to, we use that little e symbol there, meaning belongs to or is an element of the set of real numbers, and we use that double barred r. Okay, so complex numbers aren't something that we have to worry about, but it's important that we state that x is just any real number. So this notation bit here basically just means x can be anything. Now the range in this case is also unrestricted. In other words, if I want to output, so I put a number into here and the number that I want to get back, if I want a really negative number, then I would put a large negative number in for x. And if I wanted a really positive number, then I would put a large positive number in for x. And if I wanted 0, I could just put in negative a quarter. Okay, but the point being, I can get any number back out of this function. Okay, so my range is also unrestricted. And we write that by saying the range is such that, and if we let this be y equals f of x, y belongs to the set of real numbers also. In other words, my range can be anything. Okay, so belongs to, with a little e there, the set of real numbers. So as far as we're concerned, just all the numbers that we know about. Okay, so we can put anything in and we can get anything out. But there's some functions where this isn't the case and we're restricted. So if we come down here, so let's say now that our function f of x is equal to x squared this time. And again, for the ease of writing our range, we'll let y be equal to our f of x. Okay, let's start with the domain. Let's think of all the things that can go into this function. So if you think of all the numbers which can be squared, well, I can square any number. I can square a negative number, I can square the number 0, and I can square a positive number. So my domain is once again unrestricted. So we say that our domain is such that x is just belongs to the set of real numbers. Okay, so all the numbers that we're aware of, x can be any of them. If we have a look at our range though, in this case, what happens if I put a negative number into here for x? Well, for example, I put the number -2 in and I square it, I get a positive number in return. In fact, if I put the number 0 in and I square it, I get the number 0. And if I put a positive number in and I square it, I also get a positive number. So there is no number which we can put in here for x into our function, okay, which will return us a negative number. So our range must be greater than or equal to 0. And we write that by saying our range is such that our y, because that's equal to our f of x in this case, again, it has to belong to the set of real numbers, so we're not allowing complex numbers, but y has to be greater than or equal to 0. Y cannot be negative. So that's an example of where our range is now restricted. Let's take a look at another example. Let's say that our y, or our function of x, okay, is equal to the square root of x now. Let's have a think about our domain. What numbers can go into here? Well, I cannot take the square root of a negative number. I know that. So if I try to take the square root of -2, that does not work. We fail. Okay, so we can take the square root of 0. We just get 0. And we can take the square root of any positive number. For example, the square root of 16 gives us 4. So we get a positive number in return. So our domain in this case, again, has to belong to the set of real numbers. We can't have complex numbers, but our domain must be greater than or equal to 0. We cannot take the square root of a negative number. If we have a look at our range, well, if I put a negative number into here, I fail. So that's a no-go. If I put the number 0 in, I get a number 0 back. And if I put a positive number in, I get a positive return. So my range is identically restricted, in as much that y has to be a real number. Again, it can't be complex. But my output, or my range, must also be greater than or equal to 0. I can't get a negative number come back out of this function. So that's an example there of where both our domains and ranges are also restricted. Let's have a look at one more. Okay, so for example, our y is equal to our function of x, and this is equal to 5 divided by x. Let's think of all the things that can go into this function. Okay, so all the things that I can put into here for x. Well, I can put a negative number in, that's fine. I can put a positive number in, that's also fine. Okay, I can divide any number by a negative or a positive number, but I cannot divide a number by 0. That is not allowed. Okay, so we can't divide numbers by 0. So we say that our domain is such that x belongs to the set of real numbers. It has to be a real number. But in this case, x may not be 0. Okay, so that's how we could write that domain. Now our range, we can happily get really big or small negative numbers, and we can get really big or small positive numbers, depending on what I put in here for x. But there is no way that I can get the number 0 in return as an output from this function. Okay, I would need somewhere that I could put a 0 into my numerator to be able to get a 0, but we don't have that. So there's no way to find a 0. So my range is similarly restricted in as much that y, again, has to be a real number, but y may also not be 0. But it can be anything else, okay? Any other number, there is in fact a number we can put in for x to get that output in return. So if we kind of summarize, we saw firstly that when we take a number and we square it, our output can never be negative. There is no number that we can square which gives us a negative number in return. Okay, so that's our first restriction. Secondly, we saw that when we took the square root of a number, our input could not be negative. Okay, so we could not take the square root of a negative number, and our output could not be negative. There is no number that we take the square root of that gives us a negative number. Okay. Now, thirdly, we saw that when we tried to divide by a number as an input, that number could not be equal to 0. We cannot divide by 0. And as an output, we also saw that we cannot get 0 in return. Okay, and these three properties are going to be really important when we come to tackle some slightly harder problems in the next video.